Dear friends, this video is included in group interview question and recommended answers for interview question of construction plant and machinery engineer. This time, we'll talk about recommended reply 4. Can you explain the working principle of hydraulic systems in construction machinery? Answers. Hydraulic systems are a key component in construction machinery, providing the power needed to lift, push, dig, and move heavy loads. Here's an explanation of how they work. A. Basic working principle of hydraulic systems. Hydraulic systems operate based on Pascal's law, which states that pressure applied to a confined fluid is transmitted equally in all directions. In simple terms, when you apply force to a fluid in a closed system, the pressure generated is evenly distributed throughout the fluid. This pressure can be used to move or lift heavy objects. B. Components of hydraulic systems. 1. Hydraulic fluid. A specialized fluid, usually oil, that transmits force through the system. It is also responsible for lubricating and cooling the components. 2. Pump. The pump generates the flow of hydraulic fluid. It converts mechanical energy, usually from the engine, into hydraulic energy by forcing the fluid into the system under pressure. Common types of pumps include gear, piston, and vane pumps. 3. Valves. These control the direction, pressure, and flow of the hydraulic fluid within the system. Directional control valves determine the direction in which the hydraulic fluid flows. B. Pressure relief valves prevent the system from exceeding a safe pressure limit. C. Flow control valves regulate the speed of the actuators by controlling the flow rate of the fluid. D. Actuators. These are the components that do the actual work. There are two types of hydraulic actuators. E. Hydraulic cylinders. These convert hydraulic energy into linear motion, commonly used for lifting, pushing, or pulling in machines like excavators and loaders. F. Hydraulic motors. These convert hydraulic energy into rotational motion, often used to drive wheels or tracks. G. Reservoir. The storage tank for hydraulic fluid when it's not being used in the system. The fluid circulates back into the reservoir after completing its work in the system. H. Piping/tubing. The pipes and hoses transport the hydraulic fluid between components. They must be capable of withstanding high pressure and flow rates. C. Working process. 1. Power generation. The pump receives mechanical energy from the machine's engine and forces the hydraulic fluid into the system under pressure. 2. Pressure transmission. The pressurized fluid is transmitted through valves and piping to the actuators, cylinders, or motors. 3. Work execution. In a hydraulic cylinder, the pressurized fluid enters one side of the cylinder, pushing the piston to extend the arm. This is how a backhoe or excavator arm lifts or digs. In a hydraulic motor, the fluid enters and causes a rotor to turn, producing rotational motion used to drive wheels or other rotating components. 4. Fluid return. After doing its work, the fluid exits the actuator and flows back to the reservoir, where it cools down before being pumped back into the system. 5. Control. Valves control the flow and direction of the hydraulic fluid. For example, the operator controls the directional control valves to choose whether the arm of an excavator lifts or lowers, and the flow control valves determine how fast these actions occur. D. Advantages of hydraulic systems. 1. High power density. Hydraulic systems can transmit large amounts of power in a relatively compact and lightweight package, making them ideal for construction machinery that requires significant force. 2. Smooth and precise control. The flow of hydraulic fluid can be finely controlled, allowing for precise movements of machinery, such as lifting and lowering loads gently. 3. Safety and reliability. Hydraulic systems are robust and can operate under extreme conditions. Pressure relief valves ensure the system doesn't exceed safe operating limits. E. Applications in construction machinery. Hydraulic systems are essential in many types of construction equipment, such as 1. Excavators. Hydraulic cylinders move the boom, stick, and bucket. 2. Cranes. Hydraulics lift and extend the boom for hoisting heavy loads. 3. Loaders. Hydraulics power the lifting arms and the bucket. 4. Backhoes. Hydraulic systems drive both the digging and loading functions. 5. Bulldozers. Hydraulic cylinders control the angle and tilt of the blade. Understanding how hydraulic systems work is crucial for maintenance, troubleshooting, and optimizing performance, especially for your role as a field service engineer. Friends, we have provided recommended reply 4. Can you explain the working principle of hydraulic systems in construction machinery? If you require a PDF version of the message discussed in this video, kindly leave your name, phone number, and email in the comment box. We will communicate via WhatsApp or email. Also, subscribe to our YouTube channel Inframechanizer, which is completely free.